with few interactions with the boys. Hello and welcome to Education at SSBJ Online Video Tutorials. This video is for those who couldn't attend their online classes, and therefore the recorded video will be played here. Now say yes if a screen is visible to you. Okay, good. What you are watching right in front of you is a convergence of light. Converge means bringing all those light together at one particular point. Now look at these rays. All the rays which are coming from far away are generally light rays which are parallel to each other. They are parallel to each other. And when they strike on this concave surface, concave mirror reflects all the light rays back, but the way how it reflects is it converges. And now what comes next is how to draw this ray diagram. When I chuck the papers of these ray diagrams, in case if it was asked in the previous examinations of other students, I find many of the small errors which they commit, which should not be. So let me tell you what all those small errors, right? So what we require now, you just listen now, you need not draw. I'll be giving you a writing work which you have to submit in your classwork classroom app. Okay, not to send to me directly by mail. Okay, what we require is we require a scale and all other materials which are there in the compass, right? Again, let me tell you that make use of the lines which are already there on your notebook. So don't draw a line which is, in between those lines which are already there in the notebook. So that's the first thing. So if I draw the line here, then I have to place one concave mirror. I have to place a concave mirror. And you all know that concave mirror is the mirror which is curved inward. So how to do that? Generally, we just take a pencil and try to draw it. But it is better if it is, when you are doing it in the exam, you take a protractor. The protractor you have to keep and then keep it this way. Is it so? No, this is not the right. We have to just bring it up. And then you have to draw it. Right? Now, sometimes when you draw these things, we forget to show this as a mirror. Okay, many of the time it happens. So how do you show this as a mirror? You have to show a reflecting surface and a non-reflecting surface. And which side is the reflecting surface of a concave mirror? We know that this is a concave mirror. It is curved inward. Now we have to show a reflecting surface on this side. And this is what we forget. And therefore, two participants are waiting. Let me make them in. And therefore, not to forget shading of this concave mirror on other side, right? So let us assume that we have done it. Next, we have to draw light rays which are parallel to each other. And it is therefore to remind you that only those light rays which are parallel to each other And how will you draw? By using a scale. Again, you have to make use of the line which is already there on the notebook. So draw this along the line which is there in the notebook. So what happens? You know that you have already seen in the experiment, right? Please refer the previous video. It converges. And why it converges? It exactly follows laws of reflection. And what is laws of reflection? Angle of incidence is always equal to angle of reflection. So if you consider this as a plane mirror, and if you keep a protractor here, its perpendicular will come somewhere like this. So angle of incidence should be equal to angle of reflection, and therefore it bends on the other side, right? Again, you need not do that and draw, right? What you have to do is you have to fix one point before you do all these things. And what is that point? That is the point here. It can be somewhere here, anywhere, right? You have to fix that point and remember that all those light rays which will reflect back pass through this point. So it will pass through this point. In case if you take one more light ray from bottom, same thing happens. The light ray strikes here on the surface of the concave mirror and it reflects back. And when it reflects back, again it will pass through the same point. If you keep your scale like this, it's a wrong. You have to allow it to pass through the same point. And where those points meet, they meet on this line which is called principal axis. See, we know x-axis and y-axis, no? This is called principal axis. Look at the spelling. Not principal. Okay? Principal axis. And the point where it is met is called principal focus. So it is generally denoted as F. So this is called principal focus. It's actually a focus. And why it is called principal focus? Because it is right on a principal axis. And after that, the center of this mirror is called pole of the mirror. And why it is called pole? Generally, where we make a pole, if there is a sphere, right? And then these 2 points are generally treated as poles. Okay, and as I have told you that spherical mirrors are to be considered as a part of a sphere, and therefore this particular point is referred as pole, and its symbol which we take it as P. Right? So now you have understood in this diagram what is the principal axis and what is the principal focus, then the pole. Right? And there is one more thing which you should take care of. Suppose when you draw this right on your notebook, okay, how much of distance from P to F? Let's say it's 2 centimeter you have drawn, right? So from here to here it's 2 centimeter. Now again you have to fix a point exactly 2 centimeter from here, that is from F, and make another point here which is at 2 centimeter, and that point you have to show it as C. I hope I am making you clear. In case if you have any difficulty, just post in a chat box so that I can attend to it. Anyhow, we are going to interact again at the end of this last 10 minutes. We'll do it, or 10 to 15 minutes. Now, what is this C called? C is called as center of curvature. So this is center of curvature. Now, what does actually that center of curvature mean? Suppose if you cut the ball, if this is a cricket ball, if this is a cricket ball, let's say I am making it just, like a 3D type. Now, if you cut it here, you get a hollow curvature, right? Now, somewhere here, the center of this ball, it will be inside the ball, but it is not on the layer of that ball, on the body of that ball, right? So that is the point which is called center of curvature. So what does center of curvature of this concave mirror means? Suppose if you extend this concave mirror, and that is going to become a big sphere, and center of that sphere is called center of curvature. So what we have understood now is, first is principal. So when I am writing, just look at where is the principal axis. So you have a time. Then principal focus. So your eye should be there on principal focus. This one. And then after that, pole. This is pole. Then center of curvature. Right? So this is center of curvature. Now, why am I explaining this to you in detail? Because expect the question. What is the question? Draw the diagram of convergence of light in concave mirror, convergence of light in concave mirror, and show the principal axis, principal focus, pole, and center of curvature. Let me admit some more. Boys. Okay. Now, let me know that whether if you have understood, say yes. Okay, nice. Very good. Very good. That's what. Fantastic. Yes, yes, yes. And now, actually, what happens now when you actually draw it on the paper? And there, generally, we do some mistakes. And what is that mistake? The roughness is not shown here. Okay, this roughness is not shown. And sometimes when we point this C, this appears to be 2 centimeter, this will be little more. Immediately marks will be cut. Okay, just with a glance you can understand whether the diagram is correct or not. So, hoping that you all have understood, we'll go further now. Now, how to define the focus point? Now, the question is how to define the focus point. I'll come back to the previous slide only here. Defining the focus point. And where is the focus point? F. Now, listen to my sentences now. And when you write those sentences, it should be exactly what I tell you. Don't do any mistake. Right? Light rays which are parallel to each other and parallel to the principal axis. Light rays which are parallel to the principal axis after getting reflected from the concave mirror, converge at a point on principal axis, and that point is called principal focus. So what are important things to be remembered here? Light rays parallel to principal axis. Light rays parallel to principal axis. They should be parallel to what? Principal axis. You may ask me, what about those which are not parallel to principal axis? Very well, they will not meet on principal axis at one single point. They will reflect and they may pass through different point. Okay, that's why while explaining what is the principal focus, we need to specify light rays which are parallel to the principal axis, converge from concave mirror and meet at a point which is called principal focus. In addition to this definition, let me define another definition, and that is focal length. And this definition is very simple. Distance from pole to principal focus. Distance from pole to principal focus is called focal length. So this is a focal length. And what is the value of focal length in our diagram now? It is just 2 meter. Right? Just 2 meter. Next thing which I am going to tell you now is, look at this radius of curvature. Radius of curvature. And what is the radius of curvature? The distance from pole to, can you guess? Center of curvature. Is it not the radius actually geometrically? This is the radius of the sphere of which this mirror is a part. Right? Now have your attention on your screen. Focal length, suppose if I denote it as F, and radius of curvature generally denoted as small r. Now, can you tell me the relationship between F and R? Can you put that in the mathematical formula? Can anybody comment now? The relationship between F and R in just one equation form. Very good. F is equal to R. Right. Right. And that means 2F is equal to R. Correct now? Or R is equal to, F is equal to R by 2. Simple one. This is the relationship between principal focus and radius of curvature. Now you may ask me that are all these concave mirrors act in the same way what I have told you? 95% like that. But it depends on how the concave mirrors are made. So generally available concave mirrors, in the laboratory are not that fine enough. Okay, but the concave mirrors which are used in making telescopes, they are properly made and they converge almost 99% of light to principal focus. And more focusing of a concave mirror, more sharpness of a concave mirror decides the clarity of the picture in the astronomical or reflecting telescopes. which we will discuss later. Okay, right. Can anybody just tell me what is the, it's a 8:56. We have still time. So hope that this you have understood. Now next what you have to do is you have to draw this neatly. So your work is now you have to draw this and show all these what is principal axis, principal axis, principal focus, and then pole, then focal length, and then radius of curvature, and definition of focal length. So this is your small assignment. You need not hurry up. Okay. So I know that you have to sit all the way from morning to last period, almost 5 period, isn't it? 5 periods, 40 into 5, 200 minutes you are sitting. Okay. So it's a bit difficult, not good for your health also. And that's why you need not compromise with your health. In between, you have to stand up, move around, and come back and sit. Not during the period. Okay, complete your 1 hour of daily workout either in the morning or in the evening, because that will make you different from other student. You all belong to Sainik school, and that is the brand name. Okay, and over a period of time after pandemic gets over, if a Chinese school student look like like this, it's shame for our Chinese school. Okay, we should not project ourselves. We have to project ourselves very healthy, fit, and tough mentally. So take care of your health, drink lots of water, take good food, avoid bakery items. Thank you.